The universe is so big and has so much difference that it can be said to be beyond human understanding, figuratively speaking. From our tiny blue planet, when we gaze at the dark sky, we are able to catch only a little offering, since it is only a rough surface that one sees, the universe. But just how big is the universe? How far does it extend, and what is at the end of that stretch? This video will explore this more. Brace yourself for the expansion of every cell in your head. 1. Starting with the Earth, our home in the cosmos. Let's start with the aspect with which we are most familiar. The planet we live on is known to us as Earth. It is the planet we live on. Earth has a sphere shaped approximately 12,742 kilometers in diameter, which appears to be huge, especially when seen from the ground. This is a distance which can be said to allow collating multiple trips around the globe or cities of different continents. But if one looks at it in the context of the vastness of the universe, the Earth can be compared to a small cube of sand on an endless beach. Earth, although large enough to hold life and holds different types of ecosystems, oceans, and mountains, is still in a lower rank that includes other unknown objects in space. The Earth will not even rank as the largest planet in a solar system. It dwarfs everyone's imagination. Let us start, however, by acknowledging the scale of everyday things in order to appreciate the vastness of space. Earth could look very big to us, but that is actually just the very beginning of our adventure into space. Speaking of distance, we can say that distance from the Earth is on average 150 million kilometers from the Sun. This distance is commonly called an astronomical unit, which is a normal distance in space. Even though this may look like a great distance, it is nothing relative to the distances that are coming up later during the course of the space mission. 2. The solar system, our neighborhood. Returning to Earth from the previous context, we are located in the solar system. Easily navigable through, there are 8 planets and numerous moons in situ with comets, asteroids, and other objects seen in our solar system. But let's focus on the big picture. The Sun, which is regarded as the core of our solar system and the centripetal force that keeps it all intact. With a diameter of 1.39 million births, the Sun is 109 times the size of Earth. It is so overbearing in relation to the gravitational pull that 99.86% of the mass is retained by the solar system. And this solar system, in turn, is much broader. It covers the distance made from the Sun to the farthest edge of the Oort cloud, an area occupied by frozen objects that is beyond the Neptunian orbit. It gets further extended to clouds or a spherical shell made up of icy bodies and dips buried deep within the solar system. The outer limits of the Oort cloud are thought to be at a distance of approximately 1.6 light-years. A light-year is equivalently translated into 9.46 trillion kilometers. Oh, and even in our solar system, as it almost already sounds ridiculous, such distances are already unimaginable. In all fairness, it is necessary to explain that even when traveling to the outer edges of the solar system at the speed of light, it will take nothing less than 4.5 hours. With our spacecraft, we are able to move at speeds that most of us can only describe. Just a trek to the outer planets, for instance Neptune, will take decades. Nevertheless, the solar system is merely an infinitesimal of all that lies beyond it. 3. The Milky Way, our galactic home. Let us scale back a bit more to have a glance at our own galaxy, the Milky Way. This barred spiral galaxy, the Milky Way, includes our solar system and approximately 100 to 400 billion other stars. Yes, that's right. Our Sun, which too much brawn belongs to the Earth system, is just one of about a few hundred billions more in the galaxy. And many of these stars have their own solar systems, meaning that there could be a billion of these systems in isolation within the Milky Way system. Some of the estimates find its diameter to be approximately 100,000 light-years. The light year, as we made reference to in the latter portions of this thesis, is the distance within which light can travel in a space of a year, 99.46 trillion kilometers. Wavelength traveling from one edge of the Milky Way to another would take 100,000 years, even if the rate of progress is the speed of light. It is also helpful to note that the entire span of humanity's development, from the first cities to the current day, has been a few thousand years. So the concept of going from one edge of this galaxy to the other echelons is something the mind can only dream of at the moment. Nonetheless, even in a single galaxy such as this, which is only a small section of the universe, a phenomenal amount of variety is present. The Milky Way contains dwarf stars, normal stars, and supergiant stars, as well as black holes within its interior. It also contains areas of active star formation known as nebulae and remnants of supernova explosions known as supernova remnants. The same can be said of the other galaxies, where their stars and other objects orbit about a central supermassive black hole, which in this case is known as Sagittarius A stool. But though the big spiral shape of our Milky Way structure is attractive, since there are up to 1 billion more galaxies elsewhere, I think it can even be considered merely like a drop in the ocean. 4. Beyond the Milky Way, the local group and other galaxies. Further than our galaxy is a whole new universe containing other galaxies. Our galaxy is a member of a small group of galaxies termed the local group, with about 54 members. The most numerous constituents of the local group, apart from the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy, are dozens of smaller elliptical galaxies. About 2.537 million light-years from the Milky Way, Andromeda is a satellite of the native cosmic structure, the Milky Way, and is the closest nestled spiral galaxy. There is no direct way of getting there rapidly, even by traveling faster than the speed of light. This is unfortunate for visitors to Andromeda. It is about 1 trillion times more stars in their core, the Andromeda, than the Milky Way. Likewise, in estimated about 4.5 billion years, Andromeda and the Milky Way would be one and the same after crash and merging. However, although this sounds like a movie tall tale where a catastrophe prevails, most observations of the two, the Milky Way and the Andromeda merger, are rather boring, as what is mainly seen are the dust clouds rather than stars. Outside the local group, there are structures that go beyond the local group as superclusters. A local group briar is that it is not only part of the Laniakea supercluster, which is a collection of galaxies held together by gravitation. Within the supercluster of Laniakea, it spans 520 million light-years and contains over 100,000 galaxies. And yet, even this is very little compared to the observable universe. Number 5. The observable universe, 93 billion light-years across. When we talk about the size of the universe, we often refer to the observable universe, the portion of the universe that we can see, based on the fact that light has had time to reach us since the Big Bang. The observable universe is estimated to be about 93 billion light-years in diameter. That means it would take 93 billion years, traveling at the speed of light, just to cross from one side to the other. To put this into perspective, the universe is only about 13.8 billion years old, so the light from objects beyond this age hasn't had time to reach us yet. The observable universe is like a bubble, with Earth at the center, and we can only see the parts of the universe that are within this bubble. Beyond it lies the unobservable universe, which could be infinitely larger. Within the observable universe, there are at least 2 trillion galaxies. Each of these galaxies contains millions or even billions of stars. If you were to count the stars in the observable universe, the number would be more than all the grains of sand on all the beaches of Earth. The sheer scale is staggering, and it's hard to imagine what lies beyond the edge of what we can see. Number 6. The expanding universe. It's getting bigger. Not only is the universe massive, but it is also getting larger. Yes, the universe has been expanding ever since the Big Bang. Every single second, galaxies are getting further and further apart. And this expansion is a consequence of a phenomenon known as dark energy, which spans about 68% of the universe. Although not much is known about this form of energy, it is evident that it affects the rate of expansion of the universe. This expansion means that the limit of the observable universe is perpetually changing, since more and more portions of that very particular area of space itself become within reach of our observation. However, it also implies that some galaxies located at an extreme distance are receding so quickly that their emissions will at some point glide outside the visible spectrum and hence disappear from observers' sight. In the far future, much of the universe may be hidden from us due to this expansion. However, the idea of an expanding universe also prompts captivating thoughts regarding the fate of such an expansion. Is the universe going to keep extending indefinitely, getting cooler and emptier, while the galaxies continue moving in the same trend? Or rather, will the force of gravity one day put a stop to the ballooning, and instead bring about a situation characterized by a big crunch, where everything returns to a single point? Well, history will be the judge. 7. The infinite universe, a possibility? It is the case that possibly we live in an infinite universe. Although observers may examine only a small part of the universe, some theories propose that the universe can be considered infinite, with space extending infinitely in all directions. If that is indeed the case, we can only see a tiny part of the universe, which is just a patch of this great cosmic tapestry that is infinitely large. An unlimited universe conjures up inconceivable scenes. In case the universe is an infinite one, it must be filled with an infinite number of galaxies, stars, and planets. Out here could be used for the term Earth-like planets. Thus, what if there are alternate versions of you and me? With the thought of an infinite universe in mind, one cannot help but wonder what will happen, or what will be found out there. Therefore, it remains one of the most fascinating and puzzling subjects of cosmology that one can contemplate. Thanks for watching this video.